Bismillahirrahmanirrahim. Assalamu alaikum, my dear kids. I hope you all are healthy. Today it's our lesson number 47 and it's week number 14. The topic which we are going to discuss today is the least common multiple by the prime factorization. You should know what is the multiple. It's the number. When you multiply any number with any natural number, we get its and numbers, or you can say in simple words, the product of the natural number is called the multiple of those numbers. For example, if I multiply 3 with 1, 2, 3 or up to so on, so these would be the multiples of the 3. What is the least common multiple? Least means the smallest one. Common is the number that is shared by 2 or more number, that is common in all. Multiple is actually the product of a natural number with a natural number. So the least common is the smallest number that is multiple of 2 or more numbers. You can see here the 2, 3 and 4. If you write the multiples of 2, so you'll get 2, 4, 6, 8. You can write infinite multiples of 2. So let me write few here. 2, 4, 6, 8, 10, 12, 14, 16, so on. So similarly you can write down the multiples of 3 and you will have 3, 6, 9, 12. So you can see the 12 is the common number here. But here we have the 3 numbers, so I have to check the multiples of 4 as well. So what are the multiples of 4? You will multiply 4 with 1, then 4 with 2, 3 and so on. So if I write some multiples here, so I'll have 4, 8, 12 and so on. So you could see that here 4 is common between the multiples of 2 and 4, but it's not common in 3. Similarly, in the table of 2, 6 comes also. 6 is the multiple of 3, but it is not the multiple of 4. So which one is the least multiple here? That is the 12. So it's the least common multiple or the smallest number that is shared by all three numbers, 2, 4 and 3. So this will be known as their least common multiple. So the smallest multiple of 2, 3 and 4 is 12. But the method which we are going to discuss today is the known as the finding LCM by the prime factorization. So the definition of the least common multiple is LCM is actually the abbreviation for the least common multiple, and we can calculate for 2 or more numbers. The least common multiple of 2 or more number is the smallest number among the common multiples. Now see how you can find out the least common multiple by prime factorization method. Here you should know about the prime numbers, then you must know what is the meaning of factorization and what is the prime factorization. Factorization is simple, that you write any number as product of its factors. For example, you have the number 20. So you can write it as 1 times 20. Here 1 is neither prime nor composite, but 20 is the composite number. So I have split it as a product of its factors. You can write it as 4 times 5. So again, here there is no restriction on the factors. They can be either prime or the composite. Here 5 is prime, but 4 is not prime. But if I write it as product of its factors, for example, 2 times 5, then it will be the factorization. I have chosen only the prime factors like 2, 2 and 5. These are the prime factors of the 2, 2 and 5 are the prime factors, and their product will give you the prime factorization. So these three 2 are the examples of the factorization, and this is the example of the prime factorization. To find out the LCM by prime factorization method, first of all, you are going to find out the prime factors of all the numbers. Then we are going to take the product of the prime common factors and the non-common prime factor. So the formula for finding the least common multiple by the prime factorization is, we are going to find out the product of the common and uncommon factors. The prime factors can be calculated by the division, like 2 times 18, 2 times 9, then 3 3s are and 3 1s are. Now 2 times 24, 2 times 12, 2 times 6, 2 times 3, and 3 times 1. Now, in your book, it's written the prime factors, but we are going to express the prime factorization here. So this is the prime factorization of 36. Then you have the prime factorization of 48, and then lastly, from here we are going to choose the common one. Here this 2 is common factor in all three numbers. Again, this 2 is also common in all three factors. That would gives you the product of these two factors, like 2 times 2 will gives you the HCF. But in LCM, first of all, you are going to check the common factors among all three numbers, and but if there are some common numbers which are present in any two of the numbers, we'll write them once only. See, I have written this 2 once, then you have the next 2. See, the first common factor 2 is written here, then I have written this common factor. Now this 2, it's common between the two numbers, so I have written it just once. You can see it here. Now this 3, this factor is common between the 36 and 48, so I'll just write it once. See, I have written here once. Now I have left with this 3, it only occurs once. Then this 2, it only occurs once. And lastly, we have this 7 that only occurs once. So I have written them 3 times 2 times 7. So now we have taken the product of common and uncommon factors all. Now if I arrange the common factor 2, then how many times it is occurring here? It's repeating 4 times. So 2 times 2 times 2 times 2. Then we have 3 times 3, and lastly 7. So if you write the index notation for this, you'll get what? 2 raised to the power 4, 3 raised to the power 2, and 7. That is same as 16 multiplied by 9 multiplied by 7. So finally you have got the answer 1008. Now your question number 2 is, do the prime factorization of 9, 12 and 18 and find their LCM. First find out their prime factors by this division method. Then we are going to find out their we'll express each one of them as the product of their prime factors, like 9 can be written as 3 times 3, 12 can be written as 2 times 2 times 3, and 18 can be expressed 2 times 3 times 3. Here this 3 is common in all of them. This is the HCF. Now in LCM, this 3, I'll write this 3 first because it's the HCF, it's common in all. Now we have this pair of 2's that repeats in two numbers, so I've written it once here. Then 3, and this 2 is left only. Now you have 2 times 2 and 3 times 3. That is 2 times 2 is 4, 3 times 3 is 9. So what is your answer? 36. So let's try this. The prime factorization for 30 is 2 times 3 times 5. And the prime factorization of 45 is 3 times 3 times 5. The index notation for this would be remain same, because few examples we have seen that here the common factor is 3. So in LCM, I'll write it for once, but here we have this uncommon factor 3 as well. See, it's written here. Then we have the common factor 5, so I've written it once, and then 2 is left. So here 3 times 3 can be written as 3 square. 3 square times 2 times 5. So I'll get 90. From this example, you can see that this 3 is common in both the numbers. It's the factor of 30 and 45 as well. But here we have its power as 1. And the index for this 3 is 2. So which one is the largest index? That is 2. So we'll choose this factor here. 2 is repeating once, so I'll write 2 raised to the power 1. And this 5 is a common factor. It's present in both, and its power is 1. So its occurrence would be taken as 1. So you can see that here the LCM is product of common and uncommon factors. So if I write the LCM in the index notation, it would be 2 times 3 square multiplied by 5. Multiply these factors, you'll get your least common multiple, that is 90. You can check your answer, that we know that LCM is the smallest multiple that, or the smallest number that is divisible by the given numbers. So if you divide 90 with 30, you'll get 3. So this LCM is exactly divisible by your given numbers. The answer is 3. If I divide 90 with 45, you'll get 2. So again, it divides the given numbers completely, and the answer is 2. Now the next example you can see here, you're going to find out the LCM for 3, 9 and 21. Express them in the prime factorization. and also express them in the index notation form. From here I've got 3 square. The prime factorization of this would be remain 3, and this is 3 times 7. Now here this 3 is the common factor. We'll choose it's the largest index, that is 2, so you will write here 3 square. Now we are left only with the factor 7, so I'll write it as it is. So 9 times 7, that is 63. Multiply each factor the greatest number of times it occurs in any of the numbers. Secondly, you need to multiply 3 two times and 7 once. So the LCM is 63. It's the smallest number that can be divided evenly by 3, 9 and 21. Any number that is your practice work is you need to do the question number 2 of exercise 3.5, and you have to find out the LCM by the prime factorization method. Thank you.